Next presenter, Arlo Belshee with Promiscuous Pairing, what really makes pairing and mobbing work.
All right. Thank you. It's good to see you all. Well, to see you all in virtual world anyway. I hope to get a chance to get out there at a future craft. I was there a few years ago and absolutely loved it, but I am unable to attend this time. And so let's talk a little bit about promiscuous pairing, beginner's mind, and how we can be more effective at collaborating. So I want to take a step back in time to one of my great teams. I knew we had an excellent way to work when we were totally unable to do it without an egg timer. And let's look at what I mean by that. So this was 2000. We already paired 100% of the time. All of our code was written with two people working on the same machine at the same time. Now, we'd gotten there because the company was going to die. It was going to die on May 21st. Unless we had a product in the marketplace and had sold to at least two people, the board was going to shut the doors. And we weren't going to get product into the marketplace. So the company was going out, and we were just trying to figure out any way to save it. We'd read the Extreme Programming White Book by Beck. We decided to try it, and we decided to try it by the book because there was basically no real chance of success any other way. So we gave up on everything that we were trying. We gave up on our own expertise, and we just tried to do exactly what they said. Fortunately, in our team, we had an experimental physicist, right? And that experimental physicist really drove into us, try something, do what works, whether it makes any sense or not. So we just did. One of the things that we played with was pairing. And we had noticed that different pairs had far different effectiveness. In fact, the same two people on different days would have different effectiveness, even working on the same code base. And so we were trying to get a handle on what really makes us more effective, because we noted huge differences. Right? So we were trying to figure out why. And these were our results. Well, some of them. And I'll talk about them in more detail. But we were finding tremendous differences in effectiveness by things that didn't seem to matter very much. We found that the big thing was the pair swap time, but we also found that the most effective swap time was really, really hard to do. In fact, naturally, we felt comfortable swapping our partners about every 3 to 4 hours, or anything longer than that. But we found that our effectiveness was extremely low at that point. Well, it was good, but it was half of the peak. Right? So the peak, the most effective point, was also the hardest. We chose to do it at the peak, not because we like pain, we really don't, but because we all understood the data. And that's what I really want to talk about. So once we had finished discovery, once we knew what was going to make us effective, we now needed to improve. We needed to change our habits. And to change our habits, we need tools to support us. Our team chose the egg timer. And I knew we had found an excellent way to work and we're going to succeed because we chose to adopt an extremely annoying tool in order to do something that was extremely hard because we knew it would work. And it did. All right. So raises the question, should you work like we did? Now, before I answer that question, let's go ahead and clear a couple of things, make it easier to be present. So first of all resources, everything related to this talk are online. This URL and QR code will be at the end of the talk right before the Ask Me Anything questions as well. So you don't need to remember, you don't need to take pictures unless you really want to take pictures and tweet them or do whatever. Second, I'm Arlo. As mentioned at the top, I love legacy code. I'm on a mission to end all bugs in software worldwide. And I've seen it done at team scale. I've seen it done in small organizations or large organizations to take a good whack at it. So I work with big companies, ugly code bases, and get to the point where they stop producing bugs. We'll be open-ended questions at the end. I encourage ask Arlo anything. It could be related to this talk, could be unrelated to this talk. I'm happy to talk about all sorts of things. I love talking about legacy code. I love talking about coding. I love talking about collaboration and so on. So let's get back to the question. Should you work like we did? Well, not necessarily. Perhaps. There are a lot of ways to collaborate. there are many subvariations. You could work as solo individuals and meet only really at the pull request. It's the way that a lot of open source communities work, and it's the way that a lot of companies have chosen to work internally because of the habits and what we're familiar with, right? You could choose to peer, where two people are working on similar tasks. And so they each work for 10, 15 minutes separately on multiple instances of the same task. Then they come and chat for a little bit on what they discovered and go back and do it again and again and again. You can choose to pair, where two people are working on one thing at the same time, like these two people are working on that car engine simultaneously with different tools and different approaches, but working on the same thing. And you could choose to work in an ensemble as a mob, right? Everybody collaborating on one thing at the same time, bringing all the different specialties and experiences. And there are, of course, many, many subvariations. Right? All of them work, and each of them works in multiple different contexts. The thing is, intuition and ease may be misleading. We need to choose which ones we want to do, but we have different levels of skill with different ways of working. We have different levels of familiarity, right? And so there's often trade-offs. And that raises different questions about what should we be optimizing for, right? And the key thing that I just want to say is there's lots of good ways, there's lots of reasons to choose, but choose intentionally based on data. Ease can be one valid factor. If that's something that it turns out really matters to you, then measure it and involve that in your choice. And if it isn't, then by measuring and using the data that look at the things that really matter, you'll be able to make the choice that isn't easy, much like our team did. So here's where I make a recommendation about the way that we should all work. And because this is a talk about pair programming, I'm going to recommend that you change your retrospective. So that's a little bit of a left turn. Let's talk about what I really mean. So what I'm meaning is I want people to start thinking about their retrospective as serving two roles, discovery and improvement, and to use different approaches to do each. When in discovery, we use the scientific method, and when in doing improvement, we use the engineering method. Right? The immediate result of this is that it replaces opinion with data, right? And that we still use our intuition in order to make changes, but we use it to guide discovery, not to define improvements. Right? Now, that seems really bizarre and left turn. In the talk about pairing, why am I recommending that the place that you start and the thing that you really should do is to change your retrospective to a whole new set of practices? Why bother? Well, let's look at that. And I promise we will get back to some pairing and collaboration shortly. So the first thing is when we work with data, we level the playing field. Right? Most teams make their improvements on the basis of intuition and opinion. We bring together the insights of the team. We ask a lot of questions. We propose new ideas. We choose amongst them, right? At that point, we're choosing based off of the opinions. We're choosing based off who can be the most convincing. And so the person matters a lot, not just the idea, right? When you do discovery with data, the person matters and the idea matters in order to come up with the ideas, but data determines the winner. So the best idea wins, no matter who it came from. The next thing is intuition tends to lead us towards things that we know. Intuition uses the subconscious, the pattern matching, to look at history and come up with mixes and matches and ideas that we've done in the past or we've seen in the past and modify it in different ways. But all of those tend to put us in that bell curve on the left, things that work fairly well and are fairly well known in different varieties and different contexts. The only way we get to the right is by surprises, and intuition doesn't lead to surprises. Data and experimentation can. Right? So we want to be able to find the unexpected, and the best way to do that is with experimentation and data. Additionally, we want to make lots of improvements. It's much easier to get a 20% year over year improvement by doing a whole bunch of 0.5% improvements than it is by finding a few 5% improvements. 5% improvements are very hard, but very small improvements are very easy to find. The problem is when we're making our improvements on the basis of opinions, then some opinions will turn out to be right and some will turn out to be wrong. Things will fail. right? And when they fail, they'll come up in the retrospective again and again and again and again and again. And we see that problem over and over. Eventually, we find a good solution, but it can take a long time, right? Which means we get fewer changes in the year. Also, when we're choosing between options on the basis of opinion and intuition, people have to convince each other. When you have to convince people, then the people who are being convinced feel a lot of pain from the change, right? And that pain limits the number of changes that people can handle. Right? So the combination of these two significantly reduces the number of changes that we can make in the year. Right? And that change in number of improvements has a great impact on the total quantity of improvement we have by the end of the year. And the fourth reason for using data to drive our improvement cycle is because this way we can make our improvements really stick. When we have a known good solution before we make the change, something that's backed up by data and evidence that the team has done the experimentation to discover for themselves, then they can focus on the change, not on whether the change is going to work. And we can thus step away from trying to learn and discover towards having a disciplined, iterative adoption, right? And that way, what we change stays changed. So great, 4 wonderful reasons to change your retro, but that's not why we're all here. So let's talk a little bit about why we're here. Let's discuss the benefits of promiscuity, especially when we're collaborating. There are lots of ways to pair. You know, in the literature, it mostly just talks about pairing. You know, we get together, we have 2 people, and we program together on the same task. Right? And there's sometimes that you see in some places online different conversations about how the 2 people should communicate, what roles they should take. So we decided to do a bunch of experiments. We experimented with different roles. We experimented with all sorts of different variables. We found a lot of them didn't really matter. Right? But we found a few things that did. And one of those was we were looking at the swap time. You know, how long should 2 people remain as partners before one of them leaves the task and a new partner comes in? And we were doing a bunch of experiments. We were looking at mostly things like 4 hours and 8 hours and 2 days and so on. We were looking along that space because at that point, it seemed like everybody was pairing, you know, for a couple hours to a week or 2, right? And then you'd get a new partner. And we were really surprised. We found that first, swap time didn't really seem to matter, except when it got really small. Our smallest measures, 4 hours and 3 hours, started to show significant improvement over the long times. And that was bizarre. Those were the edge conditions that we expected would be outside of the area that would matter. So we would be down to the flat no improvement zone and thus know that we had found the maximum. The only reason that we checked something so low was because we expected that would get down to the invariant. And instead, it was showing there was a new local maximum that perhaps was a global maximum. So we were surprised, and we added more variations, and we started trying smaller ones. And we found this huge hump down here at 90 minutes, right? That the optimal time was to change your partners every 90 minutes. That was bizarre, unexpected, but okay, we follow the data. We can find a surprise, and then we can figure out what to do with it. The next thing that was a surprise was we looked at a couple different swaps, or different ways to swap. So if I've got 2 people and I'm working on a task, I could either keep the expert or avoid the expert. So if I have 2 people, then I swap one out, the new person comes in. The next time I swap, I could swap out I could keep the same person, right? At which point, this person that is coming and going is providing advice and knowledge and experience and other ideas. But this person who's staying is the expert on this topic, right? They're the ones that are bringing in the continuous thread of knowledge of what we're trying to do. They're bringing the continual design. They're the ones that are really owning it long-term for the team, right? The other thing that I could do is I could have my first time I swap out person on the left, right? And then I bring in someone new, and then I swap out the person on the right. And then I bring in someone new and I swap out the person on the left. And now there's no expert, right? Everyone who's there is there first as a complete newbie, as an apprentice. And then they're there as what we call the master. They've seen it once before, and then they're gone, right? And we found oddly, surprisingly, that it was best to avoid experts. Okay, so bizarre, but interesting. We also looked, and this I didn't actually publish in the original paper, but we were comparing pairing against soloing. We found for our team that soloing was slightly less effective than sort of the flat line of pairing. And subsequently, we've talked with a bunch of teams and seen other research and so on. And it seems like on average, the teams tend to find that soloing is pretty much the same velocity as pairing at the long tail over here on the right. But it'll be a little higher or a little lower depending on the team, but it's about the same. Right? So I just wanted to add that to the graph so you have a little bit of context. So having experimented a bit on pair swap time and how we swapped, we then started to look a little more into that, how we swapped and what was the impact there. So we started looking at basically it ends up being task ownership, right? And so there are a bunch of different ways that you can own tasks, and we talk about them all in the paper. But basically, the variables are we could give a task to an individual or a team, by which we mean we could have someone who's an expert in this task, story, epic, whatever it is that we're going to be doing, or we could just have people rotate in and out of it at random. Right? That's pretty similar to that keep expert or avoid experts, right? The next thing is we can change how we assign the task. So one option is that they're assigned, that you have an architect or a manager or technical lead or someone who really knows the skills of the people involved or someone who really knows these problems and can figure out how to assign them all to the right person. Or you can have each person choose for themselves based off of what they know about themselves and what's there. Right? So that's the next variable. And the third variable was we could choose them either in advance for the week. And so each person is choosing their optimal set. At the planning game, I look through the tasks, or the dev lead looks through the tasks and matches up each one to the best person for it. Or we could do it flexibly, which is that when I finish a task, then I either go choose or am assigned the next one. Right. And so when I'm choosing flexibly on demand, my skills are not necessarily going to match up as well to the tasks that I'm looking at, because I'm going to only look at the top 2 or 3 in priority, and there may not be a perfect match, right? So what we kind of expected based off of our knowledge was that we could optimize, right? That it's better to choose to match the task to the person. Seems obvious. So the column here that matches the task to the person's skills is this one. It's the lowest one. The second column here is the other one. That's where, so the one on the left is where I have an expert, my most knowledgeable and skilled person at understanding the team and the code, assigning them. The slightly better than that is each person chooses for themselves based off of their own team, but it's still not that great. All the ones on the right we're unable to match the skill to the problem, because either for these ones in the middle, you're picking off of whatever's available when you come out, which is not going to often match. It matches sometimes, right? Or the ones over here, we're avoiding experts. We have the whole team rotating through various tasks. So I'm rotating into a random task, then rotating into another random task, then rotating into a third random task, right? I'm seeing most of the tasks, and I'm working a lot on things that are outside of my skill area. So that was a surprise. We figured, like most people do, that you're going to get your best outcome by putting people on the tasks that match their skill sets. And it turns out that was the worst possible allocation. So another thing that I didn't report in the paper, but we also tracked, was red card rate. So the paper, we talked a lot about velocity, and each of these charts is comparing the velocity difference that we get. But another really important question is, what are the errors that you get? Right? And so the way we tracked that was red cards. We were working with physical boards, and we literally, whenever we had a bug, whenever we had unexpected work show up, things that weren't in the planning game, anything unusual, we would put it on a red card, stick it on the board. And then at the end of the sprint, we were doing 1 week sprints, so I say at the end of the week often, but at the end of the week, when we were counting up our cards, we could see what percentage of the things were red versus not red. And that found all of our various sources of error in just one number and could subdivide if we wanted. Right? Interestingly, we found that the red card rate, that error rate, was completely unaffected by the pair swapping strategy. It was unaffected by the pair swap time. It was unaffected by task ownership. It was unaffected by assignment to skills, anything except for one case. And that one case was that if we combined avoiding experts with a low swap time, really fast rotation, that was fast enough that we had lots of people going through, in particular, at least guaranteed we had no one living longitudinally, that both people had swapped off before the task was done, the story was done. Then we had fewer bugs. Right? Intuition would tell us that what we just did was maximize chaos, right? And yet that resulted in fewer defects and fewer unexpected things. Yet another surprise, right? Now, it was a step function. Anything else was about the same. And then that combination, that region was notably better. But notably better in this case was only a 20% improvement. So as compared to a lot of the other results that we were talking about in the paper, it was, it's nice, but it wasn't as big a deal. So I didn't really report it. But it was a very unusual result. So 3 odd surprises. And one interesting result of looking at the data here, an interesting interpretation, is that it shows why most pairing experiments are doomed to fail and not really going to show the team pairing being very effective. So let's walk through that. So the team typically starts doing individual work, right? And they're using that as their baseline. So individual work, in most cases, well, it always means that you're soloing, right? You're always working on this line, which I'd said is, on average, right on that pairing line. Second, it tends to be when you're doing individual work that you are in the situation where you assign work to specialists. The reason that people tend to do individual work is to take advantage of specialties, right? And so you're in one of these 2 columns, and usually there is a senior leader on the team, usually a senior technical person, who is helping to make sure that the right work gets to the right person. Right? So you're in this camp, right? Which is, it turns out, the lowest performing portion of the space, but you can't tell that. This is the only experience that people have, right? Then they go ahead and run the experiment. They try pairing. And when they try pairing, what most people try is, by default, we're going to pair and we'll swap partners about daily, right? And we don't think about how the tasks are assigned, so we continue to assign tasks to each person's specialty. And they'll gain a little bit of advantage from their partner and a little bit of breadth, and that's the thinking. So we're looking at that data point. And that's the total experiment that people tend to run. They just compare the 2 alternatives, pairing versus not pairing. It's really interesting because from the wider perspective of having run lots of experiments, they're comparing the kind of pairing that has basically the same inputs and thus basically the same results as the soloing they were doing before. And so their experiment tends to come out that pairing doesn't really change velocity too much. And it might improve quality, it might improve camaraderie, it might improve learning or other sorts of things. And so sometimes there's advantages there, and it'll also often be unfamiliar and painful. And so there's disadvantages, and then people go back and forth and they argue, but they don't necessarily see a strong reason to go one way or the other. And thus pairing doesn't tend to catch on. Now, we ran our data, and it was very clear, obviously, that we should pair. Right? So we tried this combination, right? And we see a 5x improvement in velocity, 500% the velocity of when we were working with soloing, right? And so it's pretty obvious to us that we should pair, but we only get to see that because we ran an experiment that was broad enough that it found the actual successful ground for pairing, as opposed to the nearby ground for pairing. Right? We got to see all the data, so it was obvious. And we only got to see all the data because we ran a real experiment. We didn't just compare 2 options. We explored the space, and we found we had the opportunity to be surprised. That right there, those green arrows, is promiscuous pairing. Now, I'll deconstruct that a little bit. So what is promiscuous pairing? It's really pairing with three rules in play. First, you're going to swap partners every 90 to 120 minutes. Now, we found that the peak was at 90 minutes when we had a small team, between 3, 4, 5 people. It was peaked there. When we got up to 11 people, the peak shifted right to about 120 minutes. We had some guesses and theories as to why, but observationally, that was what we saw for our team. So our swap time depended a little bit on team size, but it was between those numbers. Right? And the second was that we use Dark Lord of the Sith style pair swapping, which is the apprentice replaces the master, and then for some reason the foolish master hires a new apprentice who will replace them, right? And it just keeps rotating through. Right? And the third point was we always pick the least qualified implementer. We found that in the data, it was not only good to avoid expertise, but we actually saw improvements in velocity if for every story we picked somebody at random, or better yet, we took the least qualified person, the anti-specialist, and had them start the story. Right? So those were the three aspects of promiscuous pairing. Completely counterintuitive, makes absolutely no sense, right? But of course that's true, because our data found surprises, right? And surprises don't meet our intuition, which means that the resulting practice based on that data won't meet our intuition. By definition, it makes no sense. That's the point. We did eventually find a theory that explained it more than a years later. It was beginner's mind. But finding that theory didn't really change much, right? We had the practice first. The practice told us what to do. The theory and the mindset are, whatever. They aren't that important. Now, look at advice on the internet, or instruction, or classes you might take, or books. And how do they present? They usually look at the mindset first. If you're going to do agile, you need to focus on an agile mindset, right? And here are the key principles and the key ways to think about it. If you're going to do DevOps, then here are the key principles and the ways that you think about it. And everyone really focuses on those theories first. That's interesting, because that's going to replicate the intuition. It's going to replicate the opinions, and it's going to not find surprises. You're not going to find those positive outliers, the things that really impact your team. Right? So we focused on the practice first and let the theory or mindsets follow. And we found that different people would come up with different theory to explain the same data, and that was okay. Right? Which is great until a new innovation came. Mobs beat promiscuous pairs all over the place. Well, or do they? So data, right? And the answer is kind of not really, maybe, who knows, but interesting. Right? So we can list many options to collaborate, different ways to do it, and we can list different features, right? Different evaluative criteria. What are the things that we choose matter for this team? And it's interesting because there are, of course, many different things that we could choose to use as our features, as our comparison between the various styles. And different ones will matter more to different teams. So here's a set that I've looked at, but that doesn't mean that these are actually the important ones for your team. And if you look at a different set, you'll get different results, and that's okay. And then likewise, the columns, like here's a set of practices. And the general categories are pretty much the ones that are well known, but there's a ton of variations, and those variations are real. If you are doing solo programming and meeting and PRs, then it matters a lot whether you're doing trunk-based development or branch-based development. It matters if you can use stacked branches. It matters what your PR tooling is like. It matters. There are a bunch of different variables, right? Some of those turn out to matter a lot. Some of them don't turn out to matter very much. But until you run the data, you don't know which are which. So each one of these categories can be split and broken down. Much like the pairing category, I've broken down into what I call slow rotation pairing, standard traditional pairing, right, and promiscuous pairing. Right? And there's multiple ways to ensemble. There's multiple ways to pair. Right? So everything that's on here are generalizations, but here are some observations that I have seen with rough numbers that I've seen. Right. Now, these are all generalizations. I've looked at several different teams, but I've not all of these are based on really deep grounded experiments the way the promiscuous pairing was back in the time. So don't necessarily treat these numbers as the truth. They are reasonably consistent, right? And the interesting thing really is to look at the green columns. The green columns are the optimal ones that we've found for each of those categories. The blue ones are things that are good enough, that really in practice, you can choose between green and blue. Green will be a bit better, but maybe blue's just fine, right? And because different teams see different results and different teams need different things, that can put you in different columns. Run the experiments yourself and choose. But notice mobbing, ensemble programming, promiscuous pairing are both very effective for a lot of domains. And that there is at least one feature on which soloing and pairing is beat them, right? And depending on what you're looking at, other ones do as well. If you care about new hires and the ability to get a bunch of general hires, and you deeply care about some other area facet. So, for example, right now you want to hire a bunch of AI people, right? And it's a very selective market, right? Then familiarity matters a lot. And promiscuous pairing and ensembling are not very familiar to anybody, or at least not to most people, right? So you significantly limit your hiring pool, and that might matter a lot. Right? So there are a whole lot of other facets. So the key thing is run the experiments yourself and make an intentional choice. So one team did. Actually, lots of teams have. But the year after I published the paper, another team, one at Microsoft run by Mitch Lacey, reran the experiments. Promiscuous pairing versus all sorts of other style of pairing. And they found a number of things that supported our findings. And they also found one really big finding that we'd missed, which was it hurts, which is very interesting. And actually what they found was more nuanced. It has always hurt, but I used to be used to the pain. They found that the collaboration style, the promiscuous pairing, had the various benefits that we talked about. It reproduced our results, but it also amplified the effect of all the existing painful portions of their process. The bureaucracies mattered always, but they really mattered if they were promiscuous pairing. Right? The tooling mattered all the time, but it really mattered, et cetera, et cetera, et cetera. All of their normal problems were amplified. And this team had traditional retro processes. Didn't think anything of it. We didn't think anything of it. It wasn't until a couple of years after the team existed and talking and working with that team for a while that we discovered that the real linchpin was that their retro process and approach couldn't solve the problems in real time, and ours could. So when we were promiscuous pairing on our team, and one of these problems would show up and hurt, we could fix it very quickly. And so it didn't end up hurting that much or for very long. And then we'd go on and we'd do the next thing and the next thing and the next thing. And so promiscuous pairing was quickly finding other issues in our process that we would then address and move on. And so that leveraged and ramped up our effectiveness. Whereas for this other team, because they didn't have as good of a continuous improvement process, it would highlight a problem, which would then become a pain and a greater problem and slow them down and weaken them. Right? So if you're going to pair promiscuously, and if you're going to mob, and if you're going to do a bunch of these things, make sure you can change well. Now, mobbing somewhat has a better built-in change process than most of the other things because everyone is there all at once. You can pause, interrupt what you're doing, and make a change. Right? This is especially doable if you have a coach. If you don't have a coach, mobs vary. Right? Some of them have an effective change process, and some don't. Right? But the key is if you're going to work these highly collaborative, highly tuned, effective ways, then make sure you can solve the problems that show up. Which brings us to, okay, so how do we change? Right? How do I choose an approach? How do I find a problem, choose an approach, make a change my habits? There are a lot of different ways to make a change. When it comes down to it, they all have the same kind of core parts. They do them in different orders. Right? So those core parts, at some point, I'm going to generate ideas, right? I'm going to generate a bunch of things that I think might work, and I'm diverging. I'm creating more possibilities, right? At some other point, I'm going to converge. I'm going to decide between the various ideas that are out there. I'm going to choose down and narrow the set that I'm working with, right? At some point, I'm going to identify the problem that I'm working on, and not just the solutions. Right? At some point, I'm going to implement one or more ideas, right? And at some point, I'm going to verify whether the ideas that I implemented worked, right? And I can put these in, it turns out, a surprising number of different orders and get different results. There are a couple of constants, however. So the first is that the verify step is always present, even if it's skipped. What I mean is that there are a number of processes that don't intentionally do verification, don't pay any attention to verification. The result is that whatever they do either works or it doesn't. The project either succeeds or it fails. The change initiative either succeeds or it fails. It has been verified. Right? It's just that the people didn't have an opportunity to learn about that before failure happens. Right? So verify always happens even if it's skipped. Right? The next is that implementation always happens before verification. I can't verify on theory. It doesn't matter. I can only verify based off of the actual result that actually happened. Right? And the last constraint is that ideas, coming up with ideas, diverging, always happens before any of implementation, choosing and converging, and verifying. Right? So I have to come up with the ideas before I can test them. I have to come up with the ideas before I can choose amongst them. Okay? So let's look at some of the most common ways that people order these and how they change. So first, the most common way that especially large organizations change the way they work is through governance. There is some typically manager or architect or agile group that issues an edict of how we're going to work, right? That starts a organizational change management effort and swaps how teams are going to work. And this is a fairly standard organization or ordering of the things. Someone's going to see a problem, they come up with some ideas, they diverge, they choose amongst those, narrow down to something that's based off of their best information, the best way. Then we implement that. And there's usually no verification step. This is one of those that doesn't try and verify. And the reason is because there's two contexts. There's one set of people who are making the choices of what we're going to do, the blue, right? Managers and architects and so on. And there's another set of people who are implementing it, right? And those people who are implementing it don't really communicate back and forth, right? Often can't really communicate well back and forth in terms of nuance. And so nobody does the verification. The result is that it'll either succeed or fail, right? We don't know which, right? Because there's the verification. There's no real verification, and because there's one idea. Because we diverge and then converge, we come down to one idea and we go and implement it, right? And so that idea will either work or it won't. Right? Only the team knows whether it worked or not. That the communication can't really get back to the leader, and so as a result, the leader appears clueless because they will then make more changes in the same kind of direction, and some of those will succeed and some of those will fail. And it looks like the leader is unaware of the damage that they're causing by issuing all these bizarro edicts. It breaks trust from the teams to their leaders because of that lack of information coming back to the leadership to make different choices. All right. So then many teams shift and they start making changes by using some semi-traditional retro process where the team owns its own processes, its own tooling, its own whatever, right? And starts making changes, right? And the team follows the same kind of thinking. It's actually the same decision process. It's just local, right? Which is better, right? It's still usually missing verify, but it's the same, come up with a problem and ideas and choose amongst them and so forth. Right? As a result, they're testing out at any given time one idea, and that'll succeed or fail. But failure's much cheaper because if it doesn't work, you just stop doing it, and there'll be a future retro in which we try again, right, and come up with the same problem but a new idea, right? And it will succeed eventually, right? Within the team, this looks great, and you are finding and solving problems and making improvements. And when improvement doesn't work, you just roll it back, you try again. But from outside the team, it looks wasteful and chaotic because the team solves a little bit of one problem, and they go on to another one, and then they solve something there, and then they roll something back, and then they try a different direction, and then they go back and forth. It's not predictable. It's not clear what problem they're solving at any given time. It's not clear whether a change is going to work. And so it tends to break trust from leaders towards the teams. The teams feel great and they feel like they're making improvements, but the leaders learn to distrust those teams. That leads to all sorts of problems. So often teams, in addition to using this, they use another technique, which is follow the expert, right? And so you look at the various experts online who are suggesting do practice X, do practice Y in this way, use mocks, don't use mocks, do CI/CD pipelines, blah, 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 right? And they try that technique. So this one is a different ordering, right? We start with ideas that are online. We choose some of those. We haven't identified the problem yet. Note the problem is at the very end, right? We choose an idea, we implement it, we verify it and see whether it works, and then we choose the problem that we want to apply this to. Right? The result is it usually works because that technique does solve some problem. And it's fairly likely that we have a problem for which it solves. So the verify step, because we choose the problem that it will work, that it ends up working on, hey, look, it passes. It nearly always works. And thus, it looks intentional, it looks highly successful, and it reinforces trust in both directions. The problem is it solves whatever problem it solves, which may not be our biggest problem. Right? So it often misses the key problem. So let's look at how stage magicians make a choice. Stage magicians need to be right all the time. So they have a brilliant idea. And their brilliant idea is we're going to order everything so that we make the choice last. Right? Choose last. Result is they'll never fail. So stage magic, it works by, they're going to predict the future. Right? The way they predict the future is they write down some prediction and hide it in some way and give it to someone in the audience. And then they ask the audience to come up with a bunch of ideas and they implement those by some, magic process that they're doing in front of everybody, right? And they verify and see what the answer is, and then they reveal that, and then they reveal their prediction, and lo and behold, their prediction is right. And the whole thing works by having some sleight of hand, some technique that they actually create their prediction after they know what the right answer is going to be, and then they slip it in. Right? So as a result, they never fail. What they're doing effectively is they're picking only amongst the known good solutions. There may be only one. Right? They look like a super genius. This establishes tremendous trust, right, between them and the audience and so on. But stage magicians have to do this with a pre-canned problem. They design the entire thing. It's an illusion. It's a carefully orchestrated illusion, right? So they design the whole thing in a way that they can write that choice and slip it in after it becomes obvious what the result's going to be. Cool idea doesn't quite work in a business domain, or does it? So let's look at ways to change that decide last. And that's what experiment-driven is all about. Right? It solves the most important problem, which we pick the problem first. It can't fail because we choose last. Right? We look like a super genius, and we build crazy amounts of trust. Right? The only challenge is right in the middle here. We have many ideas, we implement them all, and we only choose, right? We need a way to manage that divergence to avoid analysis paralysis. And that's what data-driven improvement is about. We notice that there are two real states. There's discovery and there's improvement. We want to learn a little and we want to apply. We want to go back and forth between those states. We don't do both at once. If we start doing both at once, we get into the analysis paralysis trap. Right? We need to manage this complexity. Then of how do we have the two states? How do we have both of these processes going all at once? The process itself is too complicated, right? And the way we do that is, again, we choose last. We notice similarities between these cycles. With both of them, there's a chunk here that's at the beginning where we're planning what we're going to do, questioning, researching, creating a hypothesis, asking, creating a plan, right? Then we do something, we implement, or we try to disprove the hypothesis, and then we decide. We analyze the data and report a conclusion, or we improve our models, right? So there's some similarity between the two cycles. Right? And on the basis of that, we can structure a week that will work for either one, which allows us then, in any given week, to choose which cycle we're doing based off of the problem after we know which ones we're going to do. So that's the structure. Plan, do, and decide. During a retro, we make a plan, we pick a problem and decide which technique we're going to do. During the week, we do whatever that is, whether it's an improvement or a discovery, and gather the data. And then at the end, during the next retro, we decide. No, a couple of things here. For each problem, we choose to discover or improve. We align the week that way, right? We go back and forth. The retro, the week actually ends about 10 minutes into the retro, and the next week starts at that point. It's interesting. The week boundary is right in the middle of a meeting, right? And the retro consists of demoing the past, then deciding, then prioritizing and planning. Right? It lacks any data gathering step. The data gathering is happening during the week. We're both gathering data on the experiments and or improvements that we're running, and at the same time, we're gathering data about the pain points. That asking questions that often happens in the retro to figure out what we really want to focus on or what the problems that we're facing are. That happens instead at real time in the week. Write them down, and we just look at them in the retro. So that's the overall way that I structure the plan. And then there are some techniques to make discovery work more effectively. This is in the resources. You can reference it later. But the key idea here is measure wide. You optimize for the chance to be surprised. Right? We only really learn, we find those outliers when it doesn't match our intuition. So we want to look at the things that we expect, we assume, and try and disprove them. And improving, similar, there's a bunch of techniques, but the key idea is we're focusing on habits and on fluency. We're optimizing for uniformity and to eliminate surprises. Right? So the two techniques are opposite in their focus. Either we're optimizing to maximize surprise or to eliminate all surprise, depending on our objective. So let's look at taking it home. How do you make this talk useful? Right? It's only useful if it impacts your team. So first is choose your collaboration style. It matters. It has a big effect on velocity and bug rate and all sorts of things that probably matter to you. But you have to choose the criteria that matter to you. And on the basis of that, you have to choose between them. So run some experiments. Choose your collaboration style, but choose it based on data and then improve it consistently. Right? And to do that, the first step is to swap your retro. Change from whatever you're doing right now, which is probably a lot of data gathering and then picking opinions, to an approach that is structured and uses data to make either learning or intentional incremental improvements. That, I'd like to open up to arbitrary questions. Ask me anything related to this talk or not. I'm happy to talk legacy code or teams or anything else.
Thanks a lot, Arlo, for the great presentation. We are a little bit over time, so only the top question will be put in, which is, how do you measure pairing effectiveness?
Okay, so the truth is that matters. That depends a lot on what matters for your team. We were measuring velocity and red card rate errors. We were looking at that particularly as a delayed metric. We found that the impact was usually 2 or 3 weeks after the change in behavior. So we would reverse that correlation. We also looked a bit at the time it took new ideas to spread across the group, called that the pairnet time, the network speed of the team. But again, it matters a lot what your team really cares about. You measure that.
Thanks a lot. And thanks a lot for the whole presentation. We have a little present for you. This is you actually with less hair and less beard, but we will send it to you, and also a little notebook by Craft Hub. So look for the postman next time. Thanks a lot for having you here in Craft 2023. I hope you will return, and next time in person we can see you on stage, because Budapest awaits. So thanks a lot. Another applause from the audience, please. Yeah.
Thank you.
Thank you.